The topic of using cloud-based solutions for AI and machine learning is becoming very popular, and learning this topic from experienced people who are a part of this great team behind building and promoting these technologies is indeed invaluable. So for this, when we invited our speakers and when they accepted to run this event for the participants of Hack Together, we also decided to use this opportunity to open the event to a broader audience in Alberta. With that being said, we are pleased to see many undergraduate and graduate students, as well as faculty and research staff joining us at this event. We welcome you all, and we all hope that you are able to take something away from this experience that will help you with your projects in the future. We are grateful to have experts from Google to facilitate this event. So we have Tom Kerwitzky, who is a data and analytics customer engineer based in Calgary. He graduated from U of A with a background in computer science. Tom started with Google 6 months ago, and he enjoys helping customers to solve tough data and analytics challenges. Joining Tom, we also have Niaz Tedeon. Niaz is an AI ML customer engineer based in Calgary and joined Google 3 months ago. Prior to joining Google, Niaz had several leadership roles in consulting across various industries. She has a bachelor in applied mathematics in computer science and a master's in computer engineering. Cam Crockett is also with us today. Cam is a cloud architect on the Western Canadian customer engineering team. He graduated from U of C and spent about 10 years in software development before focusing more on design and architecture at companies like Google, where he gets to work with a variety of companies solving all sorts of fun problems. We are also grateful to have Rick Kujik here. Rick is a customer engineering manager for Google's Western Canada enterprise business based in Calgary. He has over 30 years of IT experience and enjoys helping customers leverage technology to solve their most difficult challenges and reach their utmost business objectives. Sean Mitchell, an application modernization customer engineer also based in Calgary, is also with us here today. He has worked in IT for the past 20 years and loves to help customers make innovation using the Google Cloud Platform technology to solve their critical business challenges. Last but not least, we have Osmond Ng, who is a computer engineer based in Vancouver. He's worked in the IT industry for around 26 years and specializes in enterprise modernization on IT infrastructure, cloud adoption, and data analytics. We are so thankful to have all our wonderful representatives from Google. And without further ado, I will pass it off to them to start this event. Thank you guys so much.
Thanks so much. I will take over the presentation. Okay, so thank you so much to both of you for helping set up this event and for Mount Royal University for hosting. It's always great to get out and meet some of you and see the kind of cool things you're working on. So we're really excited to share some of the things that we've been working on and help you out with the hackathon later today. So we're going to go over a few different things today, and we're going to start out just with a kind of higher level overview of some of the different AI things we're working on here at Google. Then we're going to go into how AutoML actually works, not too deep, but just to get a good understanding. Then Niaz is going to go through some use cases and show how we're actually using these technologies in the real world. I'm going to do a quick demo just so you can see what using this tool would actually look like. And then lastly, we'll do the Q&A session as mentioned before, and then also help you out with the workshop in those breakout rooms. So housekeeping, you kind of mentioned them already, but any questions, just throw them out in the chat. We'll be monitoring that throughout the event. So like if anything you see kind of piques your interest, just throw it in there. And again, stay on mute, but you guys are all nailing that so far. So yeah, we can open that up a bit later. Okay. So, so just to start, so, Google and AI, Google as a company has some of the largest number of users for, AI-enabled technologies around the world. And we actually have, 9 applications with over 1 billion discrete users, which is pretty remarkable. And many of those products, and almost all of them are imbued with some sort of AI. So I've got a few examples here that you may or may not be familiar with, but starting on the left, if you've ever used the app, Google Photos, like it's got tons of really cool AI-enabled features, right? Being able to like go in and search for, I want to see a picture of my dog, or I want to see a picture of my cat. Like, understanding what's in an image is a huge piece of AI, and being able to search in kind of those more natural language terms and organize your different faces together. Those are all big applications of AI at scale. The middle one here, with the Google Assistants, you may be familiar with that as well. I won't say the trigger word, or else 3 devices in my apartment are gonna light up and start interrupting me, which is always hilarious when we're on internal meet calls, and someone just be like, okay, just a second, never mind. But the trigger word, to be able to have that device be listening and really quickly give you an accurate text to speech, that's building on state-of-the-art natural language processing. And then finally, kind of the moonshot idea, one of our companies, part of the Alphabet division, is Waymo, right? And obviously teaching a car to drive itself, and I understand the world requires, it's probably one of the biggest applied challenges of AI going on right now, and is a really great example of our vision products being put to the test. It's kind of cool, like those cars are just covered in sensors, and they generate something like 2 to 3 terabytes of data every day. And to make sense of that, you really do have to use automated AI tools. So we do a lot of research and engineering into AI, but the goal with Google Cloud is really to bring those AI innovations to everyone, right? Whether you're a data scientist type, maybe working on research, or you're kind of higher level, maybe just trying to solve some business problems. So we have a number of different building blocks. I'm just trying to set the scene for exactly where AutoML fits. But at the highest level, we have certain tools like our contact center AI, which can help you like automate a contact center using really good text to speech and language understanding. In the middle, we have a number of like pre-trained, pre-built APIs. So for example, if you wanted to do something like translation, it's really easy to just say, here is a English sentence, here is a French sentence, one call to an API, and you can get a state-of-the-art translation. And then at the very bottom, we have things for the data scientists, the engineers, the types who are really wanting to get down into the weeds, with things like our TPUs and CPUs, which is hardware specifically designed to accelerate machine learning and AI workloads. Those are built on top of Jupyter notebooks. So I'm sure some of you on the call, maybe in the undergrad or graduates, have used some of those tools before, and that layer is really designed to help you do more and manage them more. AutoML kind of exists in the middle, right? It's not quite pre-built, but you don't have to go into code and things like that. So next, I'm just going to talk a little bit about how AutoML actually it works and is constructed and what it allows you to do. So under the hood, the goal of AutoML is to bridge that gap between custom machine learning development and the kind of pre-trained APIs. So the goal is to make machine learning models that are tailored to your specific use case with sort of a minimum amount of expertise, right? And it's pretty great for something like a hackathon where you don't want to spend a huge amount of time coding. You want to prove something out and then easily deploy it. So the goal is to go from some sort of data set. We will handle all of the training, the deployment, and then the actual serving of it. And the output in the end, just like the APIs, is a REST API that you can integrate into any of your services, but you didn't have to deploy and manage that yourself. So where does that begin? That's a kind of a cool concept, but it wouldn't be any good if the models weren't quite accurate. So to ensure that we're getting good state-of-the-art results, AutoML starts with best-in-class research. Google is a huge investor in original AI research, and we try to trickle down those investments into our different AutoML products. So a couple examples here, like you'll see some papers, but learning to learn. So that involves taking a neural network and then making a bunch of different candidate neural networks and kind of pruning them back and using these modular components of neural networks to more tailor your network to your problem. There's also things like transfer learning, where you can take a machine learning algorithm trained in one domain and apply it to another. So an example of that is our research into BERT, which is a very large general purpose language understanding model that you can then fine tune to a more specific type of problem. And then finally, things like hyperparameter tuning. If any of you have any experience with machine learning, there's a lot of different experiments and settings that you can run to get a model that runs really well. And we can automatically tune these parameters and end up with models that are quite accurate. So we take all this research, and then for each of our different problems, a different combination of these different ideas will be applied to get the best results. So you can see a couple of different specific models here, things like a linear regression that you might have learned about in stats class, all the way up to those complex neural tree architecture searches. So depending on whether you're feeding in things like text, images, video, etc., a different model will be applied to your specific problem. So, here's a slide that kind of shows what that would look like, and there's a lot going on, but these are some of the latest research things out of our Google Brain division, showing how you can actually apply the neural network-based models to things like tabular data. So if you had, for example, like a spreadsheet and you had, some columns and you were looking to predict one of the columns at the end, we could use the kind of synthesis of both of these models to get something a bit more accurate. So just to summarize, AutoML is doing a lot of this under the hood to make it as easy as possible for you to get started with machine learning. Just to wrap up here on this section. So how does this process actually work in the real world? Well, this on the right, you can see a graph which is showing the results of some different machine learning algorithms, specifically for vision, on the ImageNet benchmark, which is a bunch of thousands of different types of images, and you see how well an algorithm can identify which of the images, what's in each of them. So you'll see here that through that kind of pruning and iterative training process, AutoML can get a fairly high degree of accuracy, even state-of-the-art accuracy, but have quite a bit of a smaller model. So it's a really powerful technology. So I wish we had a bit more time. We could go quite a bit deeper into some of this, but we don't have too much time today. So now Niaz is going to go through some of the ways that people have taken this approach and applied it to real world situations.
Thanks, Tom. And could you let me know if you can hear me with no noise? Perfect. Yep. Thank you. My name is Niaz Tadayon. Good afternoon, everyone. Happy to be here. And I'd like to share with you a few use cases using end-to-end AutoML products. To give you an overview of end-to-end AutoML, if we go to the next slide, perfect. So this is the end-to-end AutoML, which is a line of products to bring high-quality machine learning modeling to everyone, as you heard from Tom. He mentioned at the beginning. So the reason is because we believe taking this approach, we could have broader impact to the real-world problems and challenges through end-to-end AutoML. And to make this happen, we already built multiple products for various ML domains, such as vision, video, natural language, translation, and tables, which is tabular data. And we're going to talk about it. First, I'd like to start talking about AutoML Vision. So as you heard, Google offers two computer vision products. So the Vision API is the version that is the product that classifies images into many predefined categories. And also it identifies individual objects and faces within images. And in addition, it finds and reads the imprinted word contained within images. So if you have a use case that you want to identify individual object or face or text, or if you want to classify your images, you could use Vision API, and it's available through REST API. It's pretty quick to use, and you can kind of see if taking this approach is going to meet your requirements. But if you have a very specific use case with very specialized labeling, or you want to classify your images instead, then it's worth experimenting using AutoML Vision to build custom model and see if doing this way is going to meet your needs. As you can see in this slide, AutoML Vision object detection enables developer to build custom model that is going to identify object for a given image with its bounding box and label. And now you may think how to use AutoML Vision to do more wonderful research work. So one thing came to my mind, and you correct me if I'm wrong, but I thought if we could detect cancer by looking at the images, if human can detect cancer by looking at the images 70% of the time, and if AutoML Vision predicts accurately 95% of the time because it uses, for example, regularization technique to provide better result, then taking this approach is gonna it's gonna provide us a good baseline. And then after that, we could put more effort toward, improving this result further and then get the research work published. So that could be example. But also I like to share with you example from one of our clients that they use AutoML Vision. So AES is a Fortune 500 global power company. They generate and distribute sustainable energy in 15 countries, and they own and manage around 33 billion assets. And their mission is basically to improve lives by accelerating safer and greener energy for future. So to make this happen, over years, AES has developed innovative drone and robotic solutions, and they put it in practice. And also they invested in the future of their workforce and increase their safety by teaching their team how to use drones to reduce their exposure to safety hazard when doing inspection of their assets, such as power lines, reservoirs, cooling towers, or it could be wind farm operations. So they work with the company measures for those drones, and you can imagine that each drone is going to produce thousands and thousands of images. So if they take the manual analysis approach, then that would take a week or weeks for a given person to detect cracks or rust or any other defects that requires immediate repair. So to improve the situation, they work with Measure and also Google Advanced Solution Labs to build a custom model using AutoML Vision and few other products from Google Cloud. And they deployed a very high quality custom model that automatically identifies those defects, and also it reduces the number of images that requiring human review. And now also we have a video that you can hear from the client to talk about this use case more in detail to tell you that how much they got value taking this approach.
Global warming is one of the big challenges of our times, if not the biggest challenge of our times. Now we really do have the technology to address the issue of carbon footprint greenhouse gases from the electric sector. The AES Corporation is one of the leaders in new technologies for renewables and energy storage. It's a Fortune 500 company. Our mission is accelerating a safer and greener energy future.
Right now we have around 8 wind farms. Each farm has different capacity, starting from 50 turbines up to 300 turbines.
They cover large spans of geography and land. They're spread across hilltops and mountainsides.
All these turbines need annual inspections. Originally, it could take up to 2 weeks to do one inspection. We partnered with leading drone service company Measure. Right now with drones, we can do it in 2 days, and this is safe and quick.
For a wind turbine inspection, we go out with our pilots, and what we're looking for is cracks or defects, things that may need to be repaired. On a typical inspection, we're coming back with 30,000 images. Spending 4 weeks reviewing images, I don't think anyone's going to argue that that's the best use of a highly trained engineer's time. How do we speed that up, and how do we make it 10x more efficient? That's where machine learning and AI comes in. We've built a great end-to-end solution using Google Cloud's tools and platform. With the AutoML Vision tool, we've trained it to detect damage. We're able to eliminate approximately half of the images from needing human review. The remaining 50% of their time can now be very focused on identifying that damage and really determining the right course of action to remediate it. Moving from reviewing images to training machine learning models, it's a much higher order employment opportunity for people, and one where we're trying to develop our team. Google Cloud has been a great partner. Their technology is consistently among the world leaders, and they're just a great partner to work with person to person. At the end of the day, we won't reach the cleaner energy future without advanced tools like machine learning.
Technology will allow renewable energy to be cheaper than conventional energy. Artificial intelligence, robotics, this is really what the future is all about.
Excellent. I hope you could hear the audio with no issue. So this is a use case. I really like it. So now let's talk about the next one, AutoML Video. This is another powerful product that we have. What it does in high level is it predicts the labels for entire videos and not just segments within videos. This is very valuable. And also it predicts shot boundaries inside the video, and it predicts label for those shots. And in addition, it uses a 1 second sliding window to predict actions, such as you can see in this page, it's like a goal celebration. And also it predicts the boundary, the bounding boxes and the start end tracks of objects. And then this is how it detects, for example, tracking a drifting car. So again, just thinking about it, why this is useful. Imagine that you are asked to analyze a large video library of soccer games to compile different actions such as goals, fouls, or penalty kicks. And this would be very tedious and time consuming. It's not something that I like to do it. So then using the AutoML video multi-label classification is going to expedite the process of predicting all those actions or classes. And you can imagine this could be very challenging because these actions could happen simultaneously in any part of the video. So that's the result is pretty good. And there is a version API, and also you can build your custom model. So the next one, let's talk about the other product from the end-to-end AutoML, which is the natural language. So similar approach, we could build custom model with minimum effort and ML expertise, as Tom mentioned in presentation. Also, we can use the API version, which is available through REST API. And this way we could upload text via the request, or we can integrate it with Google Cloud Storage, which is the container to keep the data. If we decide to use AutoML Natural Language to build a custom model this way, we could predict labels for our own specific use cases using our own training data. And in addition, we could identify entities within documents using domain-specific keyword and phrases. In addition, it also understands the opinion, feeling, or the attitude expressed in the block of text by using, again, tuned to the domain-specific sentiment score. So the next slide is kind of double down in this sentiment analysis part of it, which we could build a custom sentiment model for conversations or for documents such as emails, chats, or social media, and it uses our own specific score and sentiment scoring, which is very important. So we have full control on that part. And the next slide, which is going to be the last product in the line, but not not least, is AutoML Tables. So this is where it enables us to use tabular data using the past data to predict the future. And basically, the goal is to predict a target column by using the input features values in that rows. And AutoML Tables provides predictions either for regression or classifications. And I can find tons of use cases for this because every industry mission critical use cases can be boiled down to tabular format at the end of the day. So we can use AutoML Tables to expedite generating predictions, such as, for example, in retail could be the predicting if the inventory is going to be, if a specific product is going to be out of stock, or in terms of the price elasticity, which is going to help us to optimize the product inventory. Or it could be in finance, which could be the possibility of a large claim, or it could be measuring the likelihood of fraud could happen. Or in marketing could be we can predict the future customer lifetime value, or we can see what's the likelihood that they could churn. And it could be tons of other use cases. So I hope this quick overview gives you some ideas in terms of how you can use each of these AutoML products for different use cases. And by that, I pass it to Tom to continue with the demo.
All right. Thanks so much, Niaz. So I'm going to just give a quick high-level overview of what using this tool would actually look like. And this is very similar to something that you'll be doing in the lab. So, all right. Okay, so just for some background here, this is an example of an object detection problem that's used for detecting these parasites that cause the disease malaria. So, I'm not necessarily a biologist, but my understanding is that, malaria is a disease caused by an infection of these Plasmodium parasites. And it's actually still, despite a lot of work with various organizations on things like bed nets and vaccines, it still infects about 200 million people every year and causes about 400,000 deaths a year. So right now, the best way to identify these parasites is to have a trained biologist go through and look at actual physical blood slides and try to identify different types of cells. And of course, this causes an issue because there's only so many of those people to go around. So the idea here is this data set was a public data set uploaded to Kaggle saying, can we train a vision model to identify the different types of these parasites automatically? So first things first, you'd start by importing your various images. And these can be just, a couple sitting around on your computer, or, for something like the wind turbine example, you'd probably start with quite a few more. You could select a CSV file saying where all the different files are. Next, you can do a review of your images. So for example, if I wanted to look at these different ring parasites, I could just see them here. And then I can click on one of the images. And even if I was just getting started, I could tag them right from this interface, which is pretty nice. So I could, for example, classify this one as a ring parasite as well. So I will just cancel that one. So you'd go through this way and detect where all the different things are that are in your image, right? Now, next, let's say I have my images all ready to go. From then, I'm going to kick off a training job. So this is that kind of iterative process I talked about before, where we're refining all of these different models, you would first pick where you want your model to actually be run. So if, for example, our microscopes were connected to a network and we wanted to upload them to the cloud, you could optimize your model to be run on the cloud. Or let's say I was trying to deploy my model to something like an Android phone to be used in a mobile lab. I could actually change it to an edge deployment, and that would help push, optimize the model to be run on a lower power device. Secondly, I can pick what I'm trying to optimize my model for. So we can have higher accuracy, which is probably what we'd want in this case, or we could have a lot faster predictions if you have more of a real-time kind of use case, right? So, for example, if you were, detecting cars in traffic and you need to do these rapid fire, or some of the sports examples that Niaz talked about, that would be a better way to do it. And then finally, when you're all ready to go, you set a node hour budget, which is basically just saying, how long do you want to spend training your model? With this process, the more time you spend training the model, typically the better it will do, but it also costs a bit more. So you can kind of tune that to your exact use case. And AutoML will make a recommendation based on the complexity of your data set and how many pictures you have and stuff like that. But you could just use the default, press start training, and it will kick off that process. Now, it can take a little while to complete, anywhere from 30 minutes to a couple hours, depending on how long you want to do this for. But when you're done, your model will be trained and you can do an evaluation of it. So you can see here that for each of our different types of classes, I can go in and see which ones we did well on and which ones we might need to do a little bit more work on, right? So for example, for this ring type, because it's the easiest to say, I can see the ones that we had correctly predicted and their bounding boxes. I can see ones that are false negatives, so ones that we should have predicted but we didn't, and then false positives. So ring parasites that I should have found, or I shouldn't have found, sorry. And so going through here and kind of looking and tuning your algorithm and just looking through, you can either gather more images or maybe train for longer and push those numbers back up. Finally, let's say the model you've trained is good to go and you like it. You can deploy your model in one click to an API endpoint for further integration into your app. So I actually have a couple images here on my local device. And I'll just put one in here and let's see what we get. So in this case, it didn't find anything because these look like all good blood cells. But what if I bring in one that could be a bit worse? So in this case, you can see it's found a number of different classes of parasites. And again, this is just a nice way of testing that out. So that's kind of it for working through the AutoML, and you'll get a chance to do this in your lab a bit later. Just before I go back to that, I'm going to show a quick kind of fun demonstration from one of our websites here called the Pizza Authenticator. So this is kind of a front end someone just built as a web app that connects to an AutoML table or model that's designed to identify what kind of pizza you're eating. So if I look here, you can see I have an example of whatever kind of pizza this is. I'm not exactly sure. I can go back to here. I'll just upload the picture. And just a sec. I'll do that one more time. So it'll send that over to AutoML. And it's guessing in this case that that is a 98% chance that it's a New York style pizza. So I don't know the exact attributes that make that up, but it looks pretty good to me. I also have this one, which looks, it's a deep dish pizza, but also kind of looks like a pie. So we'll see how AutoML does on that one. And it says, pretty sure that it's Chicago style. So, you know, that's a kind of fun little example of how you might use something like this. Okay, so continuing on, you know, we've want to get kind of now into the workshop component. So there's a few kind of next steps that we'll talk about before that, and then we'll move into the Q&A. So first of all, for those of you who, you know, aren't necessarily in the hackathon, but just wanted to get started with some of this stuff, there's a really cool offer where if you're a first-time user of Google Cloud, you can get a free like $300 credit, and that can allow you to try out, you know, tools like AutoML or some of our app deployment tools and things like that. We also have like a free tier. So if you know, have some cool idea for an app and you want to find some hosting and it's not too big, you can usually run it for free just to get started. And so, you know, it's pretty easy to make your own account and just start playing around with some of these tools. And that can be a really great way to learn the platform and see what's possible. For another option is, if you're looking to kind of learn a bit more about this, is to join the Google developer group. So this is a local meetup group that's designed to kind of connect the community of developers and users of all these cool technologies. And with COVID going on, you know, it's been a bit harder to meet up in public, but they still do events and workshops really designed to help you learn quite a bit more and again, get more hands-on with these tools. So you can just search for Meetup Google Developer Group Calgary, and you'll be able to find and join that group. Now, for those of you in the workshop, we have enabled the lab this morning. And also, I believe Yasmin sent out an email with how to get started. If you haven't started yet, don't worry. We will show you how to do those in the breakout rooms. But the only difference between logging in yourself with the $300 credit and trying this in the workshop is that it's a bit more guided. So it'll actually walk you through an AutoML problem. But it's a kind of cool way to, again, try these things out. And there's more than just AutoML, right? There's labs for all kinds of different cool cloud technologies. So with that being said, that's about it for the presentation piece. And now what I would like to do is move over into some of the Q&A and workshop piece. So to do that, Niaz is going to go and read through the chat and see if there's any questions posted in there. And there's kind of panel style. She'll pick one of the Google experts to go through and relay those and kind of pick who's going to answer. Now, for the hackathon members, we do have those 2 breakout rooms. And you should have received, you know, an invite to those as well. And so what you can do in this case is switch over to one of the breakout rooms, and it'll be a much smaller room that, you know, we'll have some of our experts in. So if you wanted to ask some hackathon questions, or if you wanted to have some help with your lab, you know, you can drop over to those, and we will get those started in just a minute. So thank you very much for the time today, and I'll hand things over to Niaz for some of the Q&A.